Thank you, Willie. Yes, I will briefly introduce you to this early warning system that we have in place in Italy. And it's a sort of output of a previous project that was funded by ESA in 2020. What we aimed at was to find suitability areas in Italy, suitability for West Nile virus circulation. So we took cases of diseases, and we will show in a minute, and we developed also a web application that is freely available for anyone. So by considering climatic and environmental conditions, what we did was to observe when and where specific conditions caused West Nile transmission in specific areas. And this is how the application looks like. We have an interface with map, and from green to red, the hotspot of suitability. So we have different time predictions, because what we observe now in the platform is a forecast for the next 20 days. And we also uploaded data coming from the National Surveillance Plan for West Nile. So these are mosquito cases and mosquitoes positive for West Nile virus and animals. And we can also have a sort of patterns, temporal patterns of how the suitability changes across the years. So we clearly understand that there is a seasonal distribution of the suitability in different places of Italy, of course. And if you look at other places in the south, you see that the probability of having suitable conditions is extremely low. So this is a way to compare different places in Italy in space and in time. This is not just an application. This is something that the Ministry of Health is advising to check periodically in our surveillance plan. And this is the last point of a letter which usually accompanies the surveillance plan every year. So the Ministry of Health suggests the local authorities to check the website, to check the suitability for their specific and targeted surveillance application. So what the platform, what the system does, we worked using ground truth West Nile virus circulation. So we started from true data which were checked one by one for exact location. And we used pseudo-negative sites. We can't have negative sites because we can't check everything in Italy. So we start just from the notification system. And we associated data cube, the Earth observation data organized in a data cube, and mainly land surface temperature, night and day normalized vegetation index, surface soil moisture from the Copernicus missions, and rainfall. And for each point, we selected all the data, current data, and previous data up to 6 months before. So what the idea was what happens in each specific location now, but also in the past, in winter period or previous months. And we applied machine learning models and extreme gradient boost model, and these were the output. This is how the suitability appears in different years from 2021, 2022, and 2023. This is to show you that actually what we want to highlight is that in different years, we might have different environmental and climatic conditions. Look at here in the northern Italy in, oops, sorry, I just make a mess. Sorry. If you look at the, okay, in 2022, we had an earlier stage of the climatic and environmental conditions, which increased in the period from June to July, that was not evident in the year before or after. So we are aware that the conditions can change from one year to the other. And if we check the conditions, we might be alerted that it is necessary more targeted surveillance in specific areas. And of course, this is extremely useful, specifically at the beginning of the season, but also at the end of the season, where, of course, we can have different areas with different conditions. So the idea is what we need. We need definitely some surveillance data that are available and standardized. This is true for Italy because it was a long process lasting for years, and we managed to have a unique surveillance plan with public health data and veterinary data. The best would be to have Earth observation data ready to use, which we know is quite difficult. So this means that we need, when we develop some system, specific skills and specific expertise in these fields. We might want also to generalize this model to a wider extent. And this is one of the points that we are trying to develop in the 2 years project that we are currently running with ESA, extending to the Mediterranean basin. But of course, we have to verify some predictors and also to address questions about the spatial resolution. If we extend the range, of course, we have to reduce the resolution. But this is something that we have already checked. And for example, for this kind of model, there is not much difference. If we go from 250 meters to 1 kilometer, the correlation is very high. And of course, when data are available by different countries, by different areas, we can also think to retrain the models and better work together. Also using continuous learning for artificial intelligence, for example, which make an easier job for us and to implement and to generalize to extended areas. Thank you very much.